Okay, in the last video, we had solved this integration problem using partial fractions, and this is the answer that we obtained. But we realized that partial fractions is not the only way to solve this integral. Here we have a variable squared minus a constant squared. So if you remember the videos where we discussed trig functions, realize that that should be amenable to this technique, and hopefully the trig identity that comes to mind for you is the tangent squared of theta equals the secant squared of theta minus 1. Here in the integral we have, this is a constant of course, so we have a variable squared minus a constant squared. With this trig identity, we have a variable squared minus a constant. So we start off by saying, let our variable here, let u be equal to the secant of theta times the square root of this, which is just a, so that in the denominator, u squared minus a squared is now a squared times the secant squared of theta minus a squared. And we factor out our a squared, and we'll get the secant squared of theta minus 1, which is the tangent squared of theta. So that's the denominator, and the numerator is du, which is a times the secant of theta times the tangent of theta d theta. So, with this substitution, our integral now becomes, take the a to the outside, a secant theta tangent theta d theta divided by this, which is this, a squared times the tangent squared of theta. And these are going to cancel. So this becomes 1 over a, the integral of the secant of theta divided by the tangent of theta d theta. And let's see, there's no u du type substitution that's going to work out for us here. And I think we've confronted this type of integral before. What we did was broke things down into the basic identities. The secant of theta, that's 1 over the cosine of theta. This is the sine of theta divided by the cosine of theta. Invert and multiply. And it comes out like this. These cancel. So this now becomes 1 over a, the integral. 1 over the sine of theta is the cosecant of theta d theta. So this integral here with this substitution now becomes this integral here, and hopefully you remember what that is. That's minus the natural log of the cosecant of theta plus the cotangent of theta. So we're going to have minus 1 over a natural log cosecant of theta plus the cotangent of theta. Okay, so that was pretty easy to solve, but now our answer is in terms of theta. Our integral of interest is in terms of the variable u, so we go back to our substitution here, and we see that the secant of theta equals u over a. but we had to know what is the cotangent of theta and what is the cosecant of theta. So here's where we draw the triangle. Here's theta. The secant of theta is the hypotenuse divided by the side adjacent. So this is u, this is a, this is the square root of u squared minus a squared. And let's see, we can use this triangle now to get these theta functions in terms of the variable u. Cosecant of theta, that is the hypotenuse divided by the side adjacent. So this is u divided by the square root u squared minus a squared. And the cotangent of theta, let's see, the tangent of theta is the side opposite divided by the side adjacent. The cotangent of theta is the side adjacent divided by the side opposite. Okay, so we should be all set. We're going back to here. This is minus 1 over a, the natural log, the cosecant of theta plus the cotangent of theta. This plus this. So we're going to have a common denominator here of u squared minus a squared. And up here we'll have u plus a. Alright, so now we're saying that this integral here is equal to this. And it looks like we can do some manipulations with this if we're so inclined. Let's see, here we have the difference of two squares. So this would equal minus 1 over a. The natural log of u plus a divided by the square root of u plus a times the square root of u minus a, and that will be equal to minus 1 over a, the natural log, this will be the square root of u plus a, divided by the square root of u minus a. Or we can put all this under one square root sign. That will equal minus 1 over a, the natural log of u plus a, divided by u minus a to the 1/2 power. And let's see, this will be equal to minus 1 over 2a, the natural log of u plus a over u minus a. And again, because we're dealing now with logarithms, we can re-express this as 1 over 2a, the natural log of u plus a divided by u minus a to the minus 1 power. And we can say this is now equal to 1 over 2a, the natural log of the reciprocal of this, since this is to the minus 1 power. We'd have u minus a divided by u plus a. So this, plus an arbitrary constant of integration, is what we would get after, this course is an acceptable answer, but we can do some manipulations here. get it into this form, and that's the solution to this integral using the trig function, which is the same as what we got when we used the partial fractions. So, okay, that worked out all right for us. We're going to have some more partial fraction techniques, and the first one we considered was pretty straightforward. We'll get to some more complicated problems in some future videos.